A data challenge a day helps you master machine learning. This is DDC 31. This is for all you time series fans out there. What you have to do here is translate this series of equations into Python code. So you're generating a time series where this is the x value ranges from minus pi to plus pi in some number of points that you can specify, and y equals pi times x squared minus x cubed plus q, where q is noise. It's randomly distributed noise with a mean of 0 and a variance of 0.01. And you can see the noise here in the plot, tiny bit of noise. But if you try to find the peak here using the find peaks function in scipy.signal, you will not get this result if you just use the peak. You need to find some optional input arguments to help smooth out the result or do something to correct the result to make sure you're getting one result and not a million results as the little peaks. Okay, so if you come to my Substack, you'll see the full solution to this after seeing this cute picture of a dog working very hard on a laptop. So here is the solution. We need scipy.signal and in particular the find peaks function and of course matplotlib and numpy. Here is where I generate x and y. You can see this is pi times x squared minus x cubed plus random numbers. And then over here is where I use the find peaks function. Now, if you just call find peaks without any additional input arguments, you get this ridiculous result where all the tiny, tiny, tiny noise that we have added ends up creating all of these false peaks. These are all identified as peaks. So you can specify the width parameter that works, and you can also specify a prominence parameter. So there's actually multiple ways to get the correct answer here, multiple different constraints you can add to the find peaks function to ignore all of this little noise here.